All right, I'm gonna try this again. I put my phone on silent. I was muted halfway through. Last time I streamed, I actually muted all the way, but did. I realized that you have to. What is the word? You have to have this live screen, this screen showing in order to actually stream. Because last time I was streaming, uh, it wasn't actually streaming because this page wasn't here. I didn't realize that was a thing. There we go. There we go. There. Okay. Seems to be working. I don't need to pause the stream. I just need to mute it. Yeah, so I'm just going to work through some simple math problems just to and I'm going to stream it just to get out of my comfort zone and to try to get better at some math. So I'm going through a really simple calculus book. It's literally called Calculus for Dummies, but I'm going to see if I can solve this problem pragmatically. Is that a word? Pragmatically? Pragmatically. I butchered that. In a programmatic, yeah, I guess that's a word. Yeah, all right. Well, see if I can solve this problem pragmatically. I'm going to open up GIMP real quick because I want to kind of show you the problem. Sure, that's fine. Doesn't matter. So you have this box. Let's see if I can do this. Border. Sure, why not? Edit. Fill foreground color. So you have this box. And you got this. Looks like this. It's like a cardboard box. Border. Just like this. And then there's areas you can cut. So this is like a flat cardboard box and its length is 30. I wish I actually had like a tablet. 30 by its length and width are 30 and 30. But the height from here to here, and I'll just do a different color for this. Here to here and here to here, that is H. And then I'll do another color. And then this size right here is 30 minus 2H. If that makes any sense. And you can cut along these lines like this. So this might go terrible live streaming this, but that's kind of what it's all about, just to show that nobody's perfect. Not everyone is going to do everything flawlessly. And yeah. So let's see. Well, we know that the size of a cube or a box or whatever would be length times width times height. That would be the volume, not the size, the volume. So what we're trying to find with this box, I didn't really say that, is so a box with no top is to be manufactured from a 30-inch by 30-inch piece of cardboard by cutting and folding it, as shown in Figure 2.1, which is what I just showed you basically right here. What dimensions will produce a box with the maximum volume? So that's what we're going for, is trying to find the maximum volume. So we know that... So let's do off on the side. Let's have notes.adoc, just so I can have a writing area. let's just make I'll call it scrap.text. That'll work. So v equals length times width times height. Something we already know. We know that if we want to find the volume, we're going to have to do v of h. And I'm going through the Calculus for Dummies book, if you're curious. If we want to find the volume for this, we're going to have to get 30 minus 2h. So 2h because this length of this side and this side. So 30 minus 2h. And then we're going to have to do that times h. And that's just, so this right here would be the length, or L. This would be the width, and obviously h is the height. So that's getting our length, width, and height there. That's kind of how we would do that. Yeah, so this is probably going to be not too hard to do. And you can kind of realize that we can do, 30 times 30, which is 900 minus 30 times 2h, which is, let's just do this, write this out real quick. 30 times 30, which is 900, 30 times 30 times 30, 200. 2h times, negative 2h times 30 is negative 60h. So like that. And then we have 30 times negative 2h, which is negative 60h again. And then, so we did 30 times negative 2h times 30, then negative 2h. Wait. Then negative 30 times negative 2h, then negative 2h times negative 2h, which would be plus, just making sure I did that right, plus 4h, kind of, like that. Then we can, we get negative 120h, 20h, plus 4h, oh, and I did this wrong because negative 2h times negative 2h should be negative 2h squared. My bad. So it would actually look like this. Power of 2. And then we still have to multiply all of this by h. So what we do is 900 h minus 120 h squared plus 900 h. And that would equal our volume. Cool. Now, how can I represent this pragmatically so I could input any numbers? So, like, you could have a width and a height of any numbers and an h of any number as well. That's what I eventually, want to solve. Have a program that can do this for me instead of just solving it for like fixed numbers, if you get what I'm saying. So first, if we want to find the maximum volume, what we're going to have to do, I'm just going to work through the problem real quick just so we can see what's going on. We know for the domain of the problem, Height can't be negative. And so this would be less than or equal to h, less than or equal to 15. This is the domain for h. And it can't be less than or equal to 15 because if you think about it, 30 minus 2 times 15 would equal... h can't be less than or equal to 15 because, yeah, 30 minus 2h would be 30 minus 30, which would be 0. And you don't want a box with the size of 0 for the height or width. That would just be kind of dumb. So that's our domain. And then now we're going to do a little bit of very simple calculus. So this is our function. And we got 4h power of 2 minus 240h plus 900. That's the volume for our little box here. But what we're trying to find is the critical numbers. So the critical numbers, let me do a new page so I can describe what critical numbers are. So critical numbers are, let's say you have a graph like this. Critical numbers are where the slope is equal to 0 or undefined. So right here, you know, as you're going up the tangent line, let's draw a different color for the tangent line. You're going up, the tangent line is like, what the heck? Did I not select the color? What is going on here? There we go. So the tangent line is like this, then it's like this, then it's like this, then it's like this. Then right here at the top, the tangent line is 0. So that would be a critical point. Or, yeah, that would be a critical point. And the x value, so this would be, you know, x going this way. And y would be going this way. Like that. The critical numbers are the x values for the critical points. So if at this point there was a critical number, which there is, then that wherever x lies at that point is a critical number for that point. So we know that right here the derivative is 0. Or slope is the same thing. Slope derivative is 0. Here the derivative is 0. Here the derivative is 0. You know, here. So those would be critical points. But just because you have a critical point doesn't necessarily mean that it's a maximum or minimum. So in this case, we're going to look for maximum and minimum. So we're going to look, you know, the top. We're going to look for the top point in the local area in order to find the highest volume. So let me show you more examples of critical numbers real quick so it can become a little more obvious. So another example of a critical number would be, it says here too, right here, 0 stationary points on the derivative, and also if the derivative is undefined. So if you have any point where you can't make a tangent line, so like, I don't know, like if you have a line like this, you can't make a tangent line here, you know, because a tangent line, I'll show you what a tangent line looks like. Tangent line. It looks like this, right? And it is a straight line that touches a curve at a specific point. But you can't draw a tangent line on a really pointy tip like that because it's not a curve. So anywhere where you can't draw a tangent line, basically that spot is undefined. but it's still a critical number. So, but that would not be considered would it be considered a local maximum? I think it still would be. I'm not sure actually about that. I mean, it would still be considered a local maximum, but it's, let's see. Yeah, I'm not sure about that. I think it would have to still be a local maximum. It's just it just has no slope, and the derivative is undefined. I could be wrong about that, but I'm pretty sure that's the case. So, and also a local maximum or a critical point could also be something like this. So let's say you're going down, and then you kind of even out, and then you go down again. The tangent line over here could be like this, or whatever. It could be 0. But whenever you have a horizontal tangent line, there's something special. So a horizontal tangent line, it says actually here, let me look, which is also an inflection point, which I'll describe later. At all horizontal inflection points, which is what that is, function is either increasing or decreasing. But this is a maximum, local maximum right here. This is a local minimum. This is another local maximum, local maximum. This is still a critical number or a critical point, but it's not a local maximum. Is it a local maximum or minimum? Let me remember this. It can't be, because now I have to remember. See, if I say this stuff out loud, it helps me learn. So that's why I need to stream this stuff. It's not a local minimum. Yeah. Oh, wait, let's see. I mean, it's not really, it can't be a local maximum or minimum, because, this point is higher and this point over here is higher. So it can't be a local maximum or minimum. It's just this is just a critical number, because it's an inflection point. An inflection point is whenever, whenever you're going from a positive to a negative slope, or from a negative to a positive slope. So right here, you're going down and the slope is going down. And then right here, the slope starts going up. So at this point right here, let's do a different color. At this point right here, this would be an inflection point. This would be an inflection point. Am I saying the word for that right? Yeah, these are inflection points where the slope changes from either down to up or up to down, just like that. So probably went into too much detail describing that, but the cool thing is that you can there's a way to get the critical numbers. And if you get the first derivative of whatever your function is, and then you set it to 0 and solve, you can get the critical numbers. Now, that doesn't tell you if you have a local maximum or local minimum. It doesn't tell you that because the critical numbers, like I said before, are more than just local maximum and minimums. They're just where the derivative is 0. But you can filter out from that what their local maximum and minimums are by, if you got the first derivative or whatever, you could do something like, for example, let's say you got this point. Let's say you solved for the first derivative and you got, let's do a different color again. One that kind of stands out. I'm not good at picking colors. Pink is a very bright color that would be way different. There we go. Pink it is. So let's say you solved for this function and you got the critical points and you got, whoops. You got this point and you got this point. You got this point and you found this point. When you solved for this function, ignore that whatever is below. We're looking at this. Let's call this f of x, I guess. This is f of x. You solved, you got the first derivative, you set it to 0, solved for it, and you got these pink points. Now, how do I know if they're local maximum or minimums? And obviously, you can just look at this and be like, it's very clear here what is a local maximum and local minimum. But hang on one sec. I'll be back. Okay, I am back. I hope I still have audio. Yeah, I do. I should. Anyways, so what was I saying? Oh yeah, you found the critical points, these pink points, and a way you can figure out whether or not they are local maximum or minimum is you could like make a graph and say you found your critical numbers. Let's say this is -2, this is 0, this is 1, this is our graph, and this is 3. Not very accurate. Well, what you can do is you can split this up into, you know, we have one section here, right here. We have another section from -2 to before -2, from -2 to 0, from 0 to 1, and then from 1 to 3. We have those 1, 2, 3, 4 sections. And we can pick points in between in those sections. And if we notice a change from, you know, this section to this section, if it goes from, you know, a negative number to a positive number, then we know that that's a local maximum. Negative. If it goes from a positive to a negative, that would be a local minimum. And if we, you know, look at, you know, from here to here, these sections, from a negative to a positive, it'd be like, okay, well, that's a local minimum because it's going from a negative to a positive. And that's how we can tell where those points are. We can also do the second derivative and do something similar, but the second derivative really tells us, I'm going way into detail, like way more than we need to know, but it's more so for me remembering this crap, because if you teach, it helps you remember. So that's why I'm doing this in live streaming, even if people aren't going to watch. So anyways, what was I talking about? Now I got to remember myself. Oh, yeah, I remember. Or maybe I don't. Oh, yeah, we were talking about local maximum and local minimums. So, I think that was all I was going to say about it. And then, you know, I think the second derivative tells us, the first derivative will tell us, you know, I believe the slope, and this second derivative will tell us, I think it'll tell us whether it's concave. Let's see, look at here. Let's see. Yeah, so the first derivative will tell us the slope. The second derivative tells us whether it's curving up or curving down, if it's concave up or concave down. So, the second derivative will tell us, right here it's concave down because it's like a frown. So, yeah. And then right here it's concave up because it's like a cup. That's, the way to remember it. Frown is down, up is a cup. And then right here, it's concave down. So, yeah, the second derivative will tell us, where it's concave up or down. But anyways, let's go through this example more. Let's continue through this because I went way on a tangent. Get it? Tangent? We're talking about tangent lines. Sorry. That was a dumb thing to say. So now we can set this to 0. We'll find, first we can take this volume function that we got, find the first derivative. So if you want to find, we can use the power rule for this. So we can take the 2, put it in front, get 16 to the power of h, and then, subtract 1 from the power or whatever, 16 to the, or I'm sorry, 8 to the power of h. Wait, is this the power? Did I do this right? This was the power of 3 because, or is it? And this is the power of 2. I messed up a little bit when I did my little math here. So 30 times 30 to h times 30, we get negative 60h, and we get 30 times 30 times 30, negative 900, negative 2h times 30, negative 60h. Then we do 30 times negative 2h times this. So this is right, but the problem is we didn't multiply everything. We'd kind of multiplied by everything by h, but this would be, what the heck did I write here? 900h, 120h, the power of 2, and plus 4h, the power of 3. That's why things were looking kind of funny. So that'd be 12h to the power of 2 now, if we do the power rule, minus 240h to the power of, wait. We have to do I already wrote the answer here. This is 120h. There we go. Minus, so 2 times 120 is 240h. And then plus 900, and h to the power of 0 is 1, because anything to the power of 0 is 1. So now we have the first derivative, and we can set this to 0 and solve it to find our critical numbers like I was talking about before. So we can do 0 equals h to the power of 2, and 12h to the power of 2 minus 240h plus 900. So we're just setting it to 0. Pretty simple. Now we're going to solve for this, and we can see all these numbers are divisible by 12. So this would be, if I divide this by 12, it'd be h, the greatest common factor, h to the power of 2, and then 240 divided by 12 is, 120, or 20, I'm sorry. h, then 900 divided by 12. And the book kind of already tells me because I'm looking at the book. But yeah, 900 divided by 12, which is 75. Cool. So we got, we're slowly solving, and then we can use the trinomial factoring. So what two numbers multiply together to get us 75, and then add together to give us negative 20. So we know that it would be negative 15 and negative 5. So that would give us h minus negative 15 times h minus 5. And then we can put h on this side. And then h equals either negative 15, yeah, or 5. Oh, I'm sorry, 15 or 5. So h can equal either of those numbers, but when we solved for this, I said this was the our domain. And when we're actually finding the critical numbers, we're actually going to be in an open interval of the domain from 0 to 15. So we're not going to count 15 in here. So that's just a thing you do. And then from here, to locate, evaluate the function at the critical number 5. So now that we know, so what we're going to do is we have our, let's clear all this. Let's just delete it all. There we go. And so now what we're going to do is actually we're going to get, well, I don't need to draw anything. We're going to get the endpoints, and then we're going to also solve for our critical number we found. And typically the endpoints, maximum or minimum doesn't happen at endpoints, but it's still good to check just in case. So what we're going to do is we're going to plug this into our volume function, v of h equals 4h power of 3 minus 120h power of 2 plus 900h, like that. So that's our volume function, and then we're going to plug the endpoints, which the endpoints, so we're going to solve for v of 0, which is one endpoint, v of 5, and then another endpoint is v of 15. So we're going to solve for all of those, and I'm going to skip ahead, and instead of just solving, I already know the answers. It's 0, 2000, and 0. So now we know that when h is equal to 5, we have the maximum volume of 2000 cubic inches. This is in inches, by the way. I didn't say that this was all inches, but whatever. So now we solved that, and we figured out the maximum height that we can get to get the maximum amount of volume. Oh, what dimensions will get the most amount of volumes? So yeah, let's see if we can figure this out pragmatically too. And this might be a little bit of a challenge, but you know, it's, I don't know. Let's see what we can do. So first, what are we going to have to do? We're going to have to figure out, what is a good way to first start this off? That is a very good question. Well, we already know some things are always going to stay the same. H is always going to, that variable H, I guess that variable H can change. The 2 is going to stay the same, so that's always going to be 2. 30 and H are going to be our variables. So our variables can be, let's call it extent for the width and the height, And then H will be like our length. So void main main solve gets volume. Maybe. Let's do that, I guess. So we're going to have our extent. It's always going to, the unsigned int extent, because it's not, it won't be 0. It won't be less than 0. And then unsigned int length. Because H is actually more like the length, if that makes any sense. Let's call it length. So in this case, we know that if we want to solve for this, we already kind of got like the equation right here up here for our volume. Where's it at? Oh yeah, right here. Which is reduced, which is this. And I should really write it out like this because, you know, it's just like the proper way to write it out with the, what is the word for it? The powers are the whatever of the trinomial. What do the powers represent in a trinomial? I just forgot the word for it. A trinomial. Trinomial. The degree. Okay, yeah, degree. Yeah, usually you go the highest degree to the lowest degree when you write out a trinomial. Power of 2. And then plus 900h. There we go. So that's really the way that it should be written out. You know, if you're writing a trinomial correct, like looking correctly. So we already know that's kind of our formula. But the problem is here is that we're going to have a variable number of, we can change. So, shoot, yeah, so how are we going to pragmatically solve for this without, that is the question. So, we already know that we can do int, I'm going to start writing this out. So, extent minus 2 is going to stay the same. H is going to be the length, so we can just do length 2 times length. We can make this simple on ourselves. I'll just do A for now so it doesn't complain at me like and be really annoying. And we already know that we're going to do that twice. Times 2 times length. Just like that. And then we're going to times it by length again. So we already got our little formula here. And we're going to call A actually volume. And let's just return this. And return unsigned int. Now let's see what we get. Object, what did I do wrong? Or is not a function or function pointer. Oops. Let's see. It's not a function or a function pointer. Unsigned. Oh, I'm stupid. Times like that. There we go. Signed. Unsigned int. So let's see what happens when we type in def get volume of 30, and we didn't solve for H, but did we solve for H? Yeah, 15. Let's just see what we get for that. And let's create our make file. Build main.c. Whoops. Good enough. Cube volume. Well, that's not the right answer. So that isn't right. U is for unsigned ints. I know that. Oh, you know what? We should be doing this first. So that's one issue we have here right off the bat. Let's try 5. See what that gets us. 3,000. Okay, this is working right. Oh, no, it's not. It gave us... Oh, that number is not correct. 30 minus 2 times h times 32 times h times h. Still incorrect. So what? L is for long, but something is still wrong. Because it should be the volume at 5 should be h times. Oh, am I multiplying here and not dividing? Is that the issue? Probably. 2,000. There we go. Wow, that's way easier than I thought. So there we go. So we got a little equation to get our volume. Let's call it get box volume. Bada bing, bada boom. So that'll solve our box volume. But we need something to get the first derivative. So now we can get the volume. And we could just cheat and go through all the numbers in the domain and be like, oh, well, this number's bigger, so that's the one we want to go with. But let's not write that like this. Signed int. What should we call this? Find. What are we finding? Find. We don't need to find h because we kind of already specified that here. Well, maybe our function should solve for h for us too. That might be, more in line with kind of what the program does. So we already know that this works, so we can keep this. So that's good. But let's just say we only had the extent. And let's just forget about the length. Because we're going to solve it the way that the problem in the book does, but try to do it pragmatically. So let's rewrite this. And let's do unsigned int get box h, which is actually the length. Get box length. Let's call it that. So how are we going to do this? This is where things get a little more complicated. I have no idea if you can hear me whistle or not. What am I going to do to get the length? Well, what did we do here? We, well, H is technically the length here. So yeah, that is a good question. How would we do this pragmatically? That is a tough question, isn't it? So let's say we know the extent. So now, okay, what we're going to have to do is get a variable int extent. And then we're going to have to we're going to return h. So we already know the volume is 4. I'm going to ask, because this is actually tripping me up, I'm going to ask Gemini to see if it can give me a good way to figure this out. Just for the heck of it. I solved for h here. How would someone do this prog? I'm saying that word so often now. And C. Oh, you know what? That does, okay. Quadratic formula, that makes sense. So yeah, okay. That pragmatically, I guess you would have to use the quadratic formula. All right, I'm not going to look at what it wrote because I'm going to try to use my own brain here. So let's see if I can remember the quadratic formula. Negative b plus minus, so we're just going to do plus, and then we'll have another one for minus. Square root. We're going to have to include math here. Include math.h, and then we're going to have to include that in our make file. I think it's just -m. -lm. I think that's literally all it is. Let's just see if this builds. Didn't complain. So negative b, which I'm just going to write it out. Negative b plus minus the square root of b squared. Look at this. I'm remembering. So let's do b times b. B. Do I remember it? Minus 2. Oh wait. 4ac, right? 4ac divided by 2a. Please. Is that it? Is that it? Did I get it? Did I get it? Negative b plus, well, I already know there's a minus b squared minus, I said 4ac, but I freaking wrote 5. 4ac, and then not divided by 2a. Oh my goodness, I know it. I've memorized it finally. Probably should have memorized it a while ago. So let's keep that, but b equals, what's b going to equal? Well, okay, so a quadratic is like a, let me look at my math notes. This is why I have written math notes for myself. Not what I wanted. Still not what I wanted. ./math notes. Is that it? No. Get/math notes. All right. Math, whatever. All right. Here are my math notes because I've transferred everything to my own Git repository because screw GitHub. So what I'm trying to find, oh yeah, just the polynomial thingy. It's this is what I'm looking for. The standard form, ax to the power of 2 plus bx plus c. So now we can see that here. The problem is this is kind of unique here. We already know the first derivative, so we can kind of cheat. The first derivative kind of puts it in standard form for us, which is nice. But in order to get to the first derivative, how are we going to... Yeah, that is another trick here, isn't it? What is our... We got to figure out what our A, B, and C are. How are we going to do that? We already know this is A, B, and C, but that's if you have a defined value for 300. Let's have another function for solve for ABC. Unsigned. Let's not have it. Let's have it do this. Get box ABC. Right? This is my idea. I don't know if it's going to work. I hate writing unsigned it. I really do. I'm going to do this. What header gives you uint? I'm going to do a new chat so I don't look at that. I try to not look at that part of the text. I try to like have Gemini give me ideas, but I'm not going to just copy and paste or look at what it says. It gives me a hint, and then I'm like, all right, now I'm going to try to figure out the rest of it. What header gives you uint 16 and type, whatever. It's stdint, that's what it's called. That's what I'm looking for. Thanks. Inc stdint. There we go. So let's change this to uint 32. Why not? Type. Uint 32 type. Oh, it's because of this. That's why it's complaining. Uint 32 type A, uint 32 type B, uint 32 type C. So it's going to give us our A, B, and C. It's going to return those values. How are we going to solve for A, B, and C? That is a very good question. We can do something similar we did up here, because we already know. Let's take this, and I'm just going to keep it here just so I can see it. We know that this is kind of A, this is kind of B, and kind of C, but the problem we can tell here is that it's the square root of 3. So, let's do this. We're going to have to give this an extent. Extent. So we can do A equals extent. And we can keep this kind of, because it's not really the answer we're looking for. I'm wondering if this is standard form, if this is the square root of 3, I don't think that counts. I think we need to convert this from this to taking I'm going to ask. That is my question, is if this is still standard form. Is this still standard form for a polynomial? Or do the degrees have to be the same? I don't know. Or does it do the degrees strictly have to match? I think they strictly have to match like this. Ax to the power of 2. 2 plus bx plus c. I wrote that a little wrong. Dang it. Yes, your expression is in standard form. To be in standard form, it probably needs to be written out in terms in a descending order in your exponents. Okay. That is standard form for a quadratic. Okay, the second degree means the highest degree is the okay. Can you plug? I'm just gonna ask. What if I were to plug that equation into the quadratic formula? Would 4 be A, 120 be B, and 900 be C? Or is that not quite? Okay, so I do have to do something. Okay, I'm not going to look at that, but I get what's going. Okay, I'm starting to get what's going on here. So does that mean? Well, I guess I do have to figure this out. A equals 1, B equals. So it does have to be in that form to put it in the quadratic formula, though. That makes sense. I figured. So that means, what does that mean? We have to factor a little bit. My brain is already running at a high capacity. This is why I need to do this more. I feel like streaming like enhances my like if I record myself, I'm like thinking faster because I feel like under the pressure, I suppose. So we can factor h out of all of these. So if this is our problem, and we need to make sure that, so if we just do like one of these, we could say, we could put it back to the way it was so that it is in a form that will be correct. And then we can use a quadratic formula for this and then multiply times h. So that'll simplify things a little bit more. Which means, how do we, now back to the problem of, I am curious to see something. If I did 30 minus 2 times, and we know that 5. How does one solve this? I'm really thinking. I think what I'll have to do is literally as if I was solving this. So I'll have to do 32 times h. I think I know how to solve this. It's a little interesting, but what I'm going to do is we know our extent, so we're going to have to do extent. It's almost like times extent plus we're going to ignore h like it doesn't exist. Right? Extent times extent. This would be... I'm just using 32 type because I'm not using my... A. So we kind of already know this is... No, this would be C. Oh, no. We already know this would be C. Right? And then we know that A... Or wait. Yeah, we know how to solve for A too, because A would be we still have to ignore H. We can keep the -2. -2 times extent minus -2 times extent. Like that, I think. Okay, I think I'm getting somewhere. Wait, that would be B, actually. This would be A. No, this would be C. This would be C. This would be B. And I don't really... If I'm doing minus, I really should be doing a plus here, actually. A would equal -2 times -2. Which I don't really need to do it that way, but let's see. Let's see what we get. A, B, C, printf. I just want to see. Get box ABC. Let ABC like that. Get box ABC. And then we're going to have an extent of 30. And then we're going to input the values A, B, and C. I am kind of scared to see what happens here. And. Ooh, that's kind of right. A and C are right. A and C are right. So we're on the right track. We're on the right track here. We just effed up at B. Yeah. So -2 times extent. Why am I getting a number like that? That's still not right. What are we doing wrong? Negative 2 times 30. Negative 2 times 30 minus negative. It should be right, shouldn't it? Am I going beyond? No, 100. Negative 2 times 30 is 60, and then negative 2 times 30 is another negative 60. So what is going on here? We're doing something stupid. Very stupid. I am just going to do this. And 2 times 30, 60. Cool. Nice. That's minus 2 times 30. That'd be 0. 120. And then we're gonna do it like this. Ta-da! What? Oh, it's because I am using unsigned numbers here. I should be using signed numbers, shouldn't I? All right, here we go. Int 32 type. Duh. I'm so stupid. What did I do? Expected. Oh, yeah. I see. There we go. Still the wrong number because something is still... Oh, okay. I am saying unsigned here, which I need to do not unsigned. Negative 120. There we go. Ha ha ha. I think that gives us our A, B, and C. So now we can plug that into our quadratic formula, baby. Int 32 type A, B, C. And then we can do get box ABC. And we can plug the extent in and do and A and B and C. Plug that into our quadratic formula and fix this up a little bit because right now it looks like a monstrosity. Int x, let's just call it x. There we go. And now we solve the quadratic formula. Actually, let's return it. What would the now I already forget why the quadratic formula would solve the no. What did I ask? Oh, for h. Oh yeah, so that should be h. Turn h. Let's see if it actually gets... And wait. We're going to have to return two numbers. So actually, let's do uint 32 positive and uint 30. Oh wait, why am I using uint again? 32 negative. So positive equals this, negative equals that. Yes, no, maybe so. Remove all this. get box length, extent of 30, and this should give us our positive and negative for our quadratic formula. Positive and negative. And length equals, pretty sure that should be, yeah, positive, negative. Let's see what happens here. It should give us 5 and 15, but it definitely does not. Because I didn't do this right. Still does not. So we still didn't do something wrong, right. Because we're dividing all of this, probably need to wrap this maybe in so that it knows to do this. And this has to be on top, so maybe this might help a little bit. Let's see what that does. 15 and 15. Still not the answer we're looking for, but it's definitely closer. And it's positive, which is, it's wrong. Oh, it is. No, that is right. Kind of. Because, yeah. We're getting on track here, though. So why is this? We should be getting 5 here. For AC. Let's do b squared first, because technically that should be first, because it's still wrong. Oh boy. Oh boy. This is scary. What am I doing wrong? I feel so close, but so far away. Is it time to ask the AI? Or is it, or should I continue figuring this out? I don't know. -4 IC. I feel like I'm doing it right, but obviously this is int 32 type. Maybe it has to be a long. Isn't it LD? Int 32. How would I specify int 32 type in printf? Because I don't know. LD, that's what I did. Oh, you got to use the int type thingies. Int types. Do I need? It's that madness. Percent pry d32. Percent pry d32. Yeah, buddy. But I am not separating these with a comma. Still wrong. For my negative value, at least. All right, it might be time to ask. I don't know. It's like negative b plus minus. This should get, I would think, what am I doing? Like, what is going on here? Why am I getting 15 for both answers? All right. Ignore this. I'm pretending like that top thing didn't exist. I scrolled past it. Am I doing wrong? Oh, it's a double. I think I get it. Maybe. Let's use floats here. That's what I am doing wrong. To ABC float. I just change everything to a float. See what has type double. Okay, screw all this stuff that we did. Let's just go back to floats and see what happens. Okay. Yeah, I'm not assigning the right types of values to. I guess that makes sense. Let's, because what is it? 16-bit would be, I don't feel like 2 to the power of 40, 0 to that, if I remember. Man, I forget this. That's what sucks. I forget how much 16-bit should be this, kind of, if it's an unsigned integer, but then half of it is negative or something like that. Let's see what it recommends. Double, just change everything to a double. All right, well, okay. So if it's 16-bit, 16 minus 1, that's all of the values. But if it's a double, whatever. Let's just try double. Oh, I'm using UINT 30. Let's change this to a float. Try this again. Still gives us the same values. Brother. I'm pretty sure it's just telling me to use. It's solving for the discriminant. And I don't really, I mean, okay, yeah, I guess I could do that, but I don't need to do that here. I'm just, I don't need, it would be nice to do that because I really should be. And then change this to a double. Okay, well, let's change everything to a double. It's finding the derivative. I didn't I'm not finding the derivative yet. It's going ahead. And let's use regular square root. Let's use, yep, double. It still gives me not the right negative. I don't. What is happening? I mean, I guess it would be nice to isolate the discriminants because I know I'm using that in both things. And then just do there we go. Discriminant. Discriminant. Do not discriminate. Still going to give us the wrong answer. That was, what did I do here? Oh, I didn't do this thingy. Still not the right negative value. I'm going to It should be 12. It should be 12. Okay. So that's because they're already solving for the derivative. I'm just putting this. I'm not solving for the derivative yet. Oh, I guess, okay, maybe I should be. Because that's what this is solving for here. Ah, thank you. That makes sense, I guess. So, all right. The computer is right. The AI is right. It knows all, I suppose. Because I just want to see if my math was correct real quick. Yeah, I'm dumb. I was 15 or 5 would be for this. What would be the output of the see if my math was correct. Just do it. $15. I mean, I got 15. So I think it was right. My math was correct. I mean, kind of correct because I was solving this right here. Solving for h here. So this, I forgot that part. So let's just continue what I was doing. And now let's take the negative, and we're still going to have to... This solves for h here, but then we're going to times it by itself, I guess. Right? So x positive. Positive equals x positive times x. Whoops. Negative equals x negative times x negative. So this should really give us the answer for v of h. Not the derivative, though, of v of h. But that's what we need, actually. So we really should do what it was kind of saying. So that sucks. Our math is still wrong. I was going in the right direction, but still wrong. So, you know what? I can still kind of use what I have, though. Because... let's have a function for void find quadratic. So I don't have to rewrite this. And double A double B double C. And just kind of copy this and change it to the way it was. Yeah, I know. And your return double negative double positive. And I guess I'll check if the discriminant is greater than 0 or whatever. Nah. I forgot. If it's greater, what does the tell us quadratic formula? What is the secret formula? If it's greater than 0, you know what? Screw you. I am... something like that. It tells us different things. Greater than 0, 2 distinct roots. 1 real root. So if it's equal to 0, if it's greater than 0, we're going to have a positive and negative. if it's equal to 0, discriminant is equal to 0, then we'll just have 1. And we should be... we should have a way to determine how many outputs we have, I guess. Int a type out size, I guess. Why is that an error? Int, there we go. Size equals 1. Oh, 2. I suppose. There we go. Yeah. 0 real roots. Else discriminant is less than 0, reach size equals 0. What's wrong? Unsigned char. Does it really think that's... Is it because... Oh, else if. Okay. That was a weird error message for that. It wasn't even describing the right thing. So the size will tell me the output, I guess. Now we want to get we want to get the H for the find first deriv length. I should be... That makes more sense. I would think. But now it gets a little different. Because this would solve for the first... This would solve as if they're... and then we times all of this by... I'm just going to keep this here. Times... I might do this like this. Comment that out for now. Okay. We might not need all this. A, int B, int C. It's fine. The quadratic formula will solve for H for us, so quadratic ABC size. Okay. A, B, C, and maybe I'll swap these around. Positive and negative. Cool beans. And we're just going to pretend like the size doesn't exist, and we're just going to go with positive value for now. And then we'll handle that later. So I'm going to look at what they did. See, that's if yeah, they're solving this a little bit differently than I'm trying to do it. I'm trying to make it to where you can put any. I think they are. For get box ABC. Account for setting your own H. Let's see. See if it gets the size for us. Yeah, it does. So that's working correctly. But the issue is it's not the first derivative, it's just the volume. It's just this. And it's not even multiplying it by h. So it would really be like that. I would so the volume of h would equal that, but then how do we get the first derivative of that? And I guess what we could do is let's solve without h. Oh. I think I can do that. No. I have to put it back into that form. Let's so this is as if, so then what we could do, this is technically to the power of 3. How would I set this from the power of 3? Okay, I'm going to have to do some different kind of math here. I have to figure out a I think I do have to solve for h beforehand, though. So I think I kind of was, I was having the right approach. So now if I know h, we know that we can say that maybe, and then something times length to the power of 2 would have to... Wait. I need this. This would be 4. So now it would actually be 4 times length. 4. Maybe I'm overthinking this. A times 3 power of 2. I'm probably overthinking this. I don't know what to call this right now. That would equal our first I'll just call it a maybe I'm on the right track. B equals B times 2. Yeah, all right. And then C is like A, B, and C prime kind of. C is just C. I'll just to make it more straightforward, I'll just do length to the power of 2, so we'd have to do like times length times length, and that is not times length. Let's see what's gonna happen here. Just make everything double. Why did I do that? Oh well, I'll change it. Let's type double. So we know. So now we need to solve. We can do return, or let's just printf. A minus B getting A, B, and C here, but then how do we know? Let's not multiply it by length yet. Let's just see what happens. What values we get here. 12, negative 120, and it's still not right. I'm close. It should be negative 240. So this is right. 12, negative 240, and 900. So I'm getting close here. Now, I define two numbers that, how am I going to programmatically find two numbers that multiply to 75 and add together to 20? That is an interesting thing to try to figure out here. How am I going to do that? Oh, my brain is getting overloaded here. Get in it. There we go. So I can actually save what I've done. How do I find two numbers that multiply this? And then we have to set it, oh, even before that, we have to set it equal to 0. How am I going to programmatically do that? This is where it kind of, doing things this way kind of sucks. Let me put this back in this function. Get box ABC. Extent. Oh. See if I did that right. Yep. All right. So now we broke things down into smaller functions here. And it's getting a little bit more confusing. I'll be right back. All right, I am back. Yeah, we gotta solve for as if it a so a minus b plus c. We have to solve or a plus b plus c because we already know it. We have to solve it as if it was equal to 0. So now somehow 0 equals 0 equals a plus b plus c. And figure out what that would equal if it equaled 0. And I still feel like I'm overthinking this in some way. But yeah, if I want to, so technically, just give me more colors. We're gonna. I'm not on the pencil tool. We're gonna cross off this. Whoops. This, and this, and set, and have all of this be like some variable. It doesn't really matter what the variable name is. You can name it X. So if you're confused about what I'm doing, and that's the approach I'm going towards, is solving the same problem, but be able to put any variable in here for this. Instead of just 30. This is why it's making this problem a little more confusing for me. Okay. So what are we doing here? We're finding two numbers that multiply. We're dividing each by 12, but we can't do the same. Let's see if I change the extent, like if I can go with the same approach. Probably not. For different extent. So if it was like 40, $12, 3. I just want to see this. So that would be would it always be a greatest common factor of 12? Like, because I'm pretty sure these numbers are. I mean, not, yeah, it's definitely not. I'm going to ask again. Yeah, but I get what you're doing, but this is not. I am overthinking this. I'm pretty positive I am. Oh, if I already have A, B, and C, I can use the quadratic formula. Duh! Is this really... Please. If this is all I had to do, I'm gonna be so upset if, like, a... Let's set this back to 30, though. Oh my goodness, I think that's all I had to do. Let me just print off the size, too. It should have 2. 2. Okay, perfect, perfect, perfect. So we got the positive. Let's print off the negative as well. I was overthinking it. My intuition was right. Negative and positive. I'm not doing a new line, but just do a new line before. 5 and 15. Look at that. We got the right numbers because I was overthinking it. Sorry, I ignored what you said because my brain realized I was being dumb. There we go. Yeah, buddy. That's what I'm talking about. That's what it's all about. So if we got 5 or 15, let's just say if size. See. Whoa. We'll have to do something different if size is equal to... Let's use our... Let's get the quadratic formula. Find quadratic is like the thing we're going to be using the most. Find quadratic for... We're going to solve as if h is equal to 5. So what we're going to have to do is plug in that formula. We already have A, B, and C, right? That's values we'll need. So we're going to have to do printf. I'm solving this one way or the other. A times length, and that to the power of 2, so we're going to have to do that twice. A times length to the power of 2. And then we got that first variable, and then plus our B times length plus our C. I am like really worried. I'm like terrified right now. Okay, this is like crazy. No, we don't do length, we do pause. All right. I'm like really nervous because 5, 15. Oh, we're printing off a ton of stuff. What did I get? The last value is 0, so that can't be right. I think I done messed up. Yeah, it's 0. So we're still doing something wrong. I feel like I'm getting closer, though. Oh, wait. I know what's going on here. It's times 3, actually. Yeah. And then this is, I think, No, I don't think. Let's see if we got the right values for A, B, and C. I don't remember. B, C. For negative 120 and 900. Oh, yeah, I got the right values. And oh shoot, but it's still not right because I really have to be using this and then solve, I believe. Yeah, I think 12 negative 240. But A isn't the right value. Oh wait, yeah, 12 negative 240 900. And then I think I have to take that and delete this, delete this, delete this. Okay, I go like this. That still gives me 0. Why does this give me 0? Oh, I'm doing not position, but this should be length. That is not right. Oh, no, that's right. It should be because we're plugging in that for H. F%. A, whoops, A, B, C, and This is H, which is pos. Just see if we got all the right things here. A, B, C, and then... Oh, I see. Okay. Negative. Let's see what that equals. 5. So maybe that's literally why... Maybe I was actually getting... No. I do have to punch it back into here. $2,000. Oh, that's it. Oh my goodness, I did it. Yeah, baby, that's what I'm talking about. That's what it's all about. Oh, that was a mind-boggling experience. I'm just going to save it at this point. Solved. I'm so happy. But that's only solved if it's 15. We have to solve the endpoints too. So we really should do v as if v is equal to 0 and 15. So now we're going to print f for positive, which should be 0 anyways, but I don't know why I'm not just... There we go. And then we're going to solve as if it's 0, it's already... We already know the endpoint for 0 is 0, so it's kind of like pointless. So we really just need to solve for v equals 5 and v 15. Yeah. All right. Because v of 0 is always going to be 0. I would think. No, not necessarily. Because it, yeah, no, not necessarily. It would just return whatever. No, yeah, it would be always 0 because we're following this. Duh. Yep, so it would be pointless to do that endpoint. Pointless to do that endpoint. Now, what if size is equal to 1? Now we have to solve for that. So it's not, we're not quite done. Let's do a switch. Switch. For size. Case 1. Case 2. I like switch statements. I know people have debates about whether you should use them, but I don't know. I like them. I feel like it's just like a C thing to do. That's how I say it. Am I still streaming? I hope so. Cool. I don't even know what I did here. Okay. Now what happens if it's equal to 1? And then we're going to have to compare what's the greatest out of both of these. So technically, we're still not done here. int. Let's call this v5 or v0 or yeah, v5. And let's call this, I don't know what. What did I do? Extraneous. Oh, I don't need this. There we go. Should be 0 and 15. I mean, I guess it doesn't need. Let's just have it equal v. Just name it this. So I kind of messed up then. Oh, it's not a float. There we go. So if b return a double, and then if v1 is greater than v2, return v1, else. Can I do an else like that? I wonder. I don't think I can. Yeah, I think this has to be in a block like this. I think it has to be like that, yeah. Otherwise, return, I don't know, I'm just gonna return 0. Now we get the length, double. Get, let's rename this function, get first derivative length, get box max volume. Let's go, baby. Yeah, we got the max volume, baby. That's what I'm talking about. That's what it's all about. I'll just call this almost. I don't, for lack of a better name. There we go. Always add your break. I wonder, like, is it hurt if I add it? I probably should add it outside, you know? I don't know. So now in the case it's just 1, that means we literally just return. You know, we could simplify this even more. Case 1 or case 2. And by default, no, let's not do it that way. I don't really know how I would set that up right now. So I just kind of do it the simple way there for the moment. And otherwise, if it's case 0, just return -1 as if like there was an issue. And then break. Maybe not the cleanest way to do it. Let's try. I think that's it. I mean, I kind of need to test this a little bit more, but I think I did it. But I mean, it does give you the right value for, 30, but whether or not it actually gets you the right value for other I don't know. Yeah, I don't really know whether or not. Let's revert this. Maybe ChatGPT or AI will be able to read this image and tell me without me having to run tests through it, because I don't feel like running tests, to be honest. Let's see. But I think I got it. I think I got it. But maybe I don't. Maybe I just it's done. It's poor. Maybe my code is bad. Probably is, most of the time it is. There's always something wrong with your code. All right, let's see if ChatGPT can. I'm gonna give it this picture. Actually, let's full screen this, and I'm gonna do one of these. Get that out of full screen. What I'm trying to solve this problem programmatically. What dimensions will produce a box with the maximum volume? This box with no top is to be manufactured from a 30-inch by 30-inch piece of cardboard by cutting and folding it as shown in this picture. The dotted lines represent where to cut. This is my program to solve this. Is this correct? Oh, dang it. So what's the issue here? Oh, sign errors. Oh, shoot. It's right. Okay. Yeah, I didn't think about that. Shoot. No, it's right. I did do that. Oh, dang it. Oh, no. You're right, because this negative sign here. And maybe because of the shoot. This will always be 4, so I can just set this to 4. Simplify this. What can I do for this? We already know that B is going to be, needs to be 120, so. It like it like took so much crap out. Thank you, ChatGPT, for making that look so easy. But it's doing length. I'm just gonna ask if this fixes the sign errors. Oh, what the? You're right. I did do that, didn't I? Be like this. Is it unnecessary? I don't know how to not use the first call, to be honest, to find quadratic. And, ChatGPT, I mean, AI could be lying to me, but oh, you're right. I didn't check the. Well, okay. Well, it's fine. This version matches the math. Okay, cool. I don't really want to know that right now. I just want to know if the math is correct. I think I'm getting closer though, but I feel like something still isn't quite right. Will this still solve the if I pass other numbers to get box max volume that are not 30? I could write test. Yes, but only if the card box is a square. Aha. Okay. Rectangles. Well, I'm not looking for rectangles. I'm only looking for squares, so that's fine. Integer trap. You defined. This works for whole numbers if you ever. Where? Int extent. Oh, okay. Oh, I see. And then I cast it to a. Oh, shoot. You're right. I did do that. All right. All right. There we go. That makes it a little bit better. All right. All right. If the cardboard box could only be a square, would this work? Okay, it's offering cleanups because your main function. Oh, okay. Well, I don't need to do that, but I think I got it. I think I figured it out with a little bit of help from AI, a little bit. But yeah, I don't know. Hopefully I was streaming that whole time and hopefully I got it all. But yeah, that was fun. I didn't know if I could do it, but I figured it out. Thanks if you're watching. I don't even know if anybody watched. Let's see. Did anyone watch? I don't know. Well, that sucks because I did all this work and got no viewers. I don't think I did. All right. Well, thanks for watching, I suppose. I'm going to stop.